Alright, in this video we're going to determine the x-intercepts for quadratics. Now it's not always straightforward to factorize quadratics because not every quadratic is easy to factorize, but you can complete the square for every quadratic, and then from there you can decide whether there are actually any x-intercepts. So what we're going to do with this one, question 1, is factorize by completing the square, determine the turning point, and determine whether the turning point is a minimum or a maximum. And then do a rough sketch and state how many x-intercepts it will have. Now, question 2 says state what the x-intercepts are. So we're actually going to look at a few examples and do question 1 and 2 together. Now, in the previous video, I did show you how to do it on CAT, so I'm not going to do that here. And then for question 4, I think you'll be able to do because it's something that I've explained over and over again. So we're just going to focus on question 1 and 2 in this video. All right, so let's look at the very first one. We're going to complete the square, and hopefully by the time you've watched this, you know how to complete the square. Okay, so we do x squared minus 4x, then we take the coefficient of x, which is -4, divide it by 2 squared. Because we've added that, we need to also take it away because we can't change the quadratic. And then don't forget the plus 2 on the end. So I keep my terms from the quadratic, x squared minus 4x and 2, and I've just included this because that's how we complete the square. Okay, so x squared minus 4x, -2 divided by 2 is -2, and then -2 squared is 4. Then we've got to take away 4 and plus 2. Now, the reason, remember, we do this is so we can get the perfect square here, which is x minus 2 squared, and then minus 4 plus 2, which is minus 2. Now from here I can see that we have a turning point, and it's a minimum turning point because it's a positive parabola. We have a minimum turning point at 2, -2. And we have 2 x-intercepts. Now the reason I know we have 2 x-intercepts is because this is a positive parabola that's been shifted down the x-axis. Okay, so 2 x-intercepts there. Now to find out what these are, let's just clear all this because we're not going to have any room otherwise. So we have y equals x minus 2 squared minus 2. You can see we've got the difference of perfect squares because we have this minus sign separating this bracket and this constant. So remember the difference of perfect squares, a squared plus b squared is a plus b, a minus b. And all you need to do is identify a and b. So in this case, the a is going to be the square root of this first term, which is just x minus 2, and b is the square root of the second term, which is just square root of 2. Then we substitute it back into here. So a is x minus 2 plus b, so plus root 2. And then your second one is going to be x minus 2 minus root 2. Okay, so that's now in factorized form. Now you wouldn't have been able to do that just from here. You wouldn't have been able to say, well, 2 numbers when multiplied give me 2 and when added give me -4. But here they are. Okay, so this is how you would use completing the square to find your x-intercepts. So your equation in factorized form. There is another way to do it, so we'll actually it's the same way, so we'll just leave it as this. Okay, so using the null factor law, minus 2 plus root 2, so we take this factor and let it equal 0, and the other factor and let that equal 0. So that means x is equal to 2 minus root 2, or x is equal to 2 plus root 2. Another way you could have done it is just by letting this equal 0, you would get exactly the same answer. And your y-intercept, so we may as well do that as well. Your y-intercept, if it's already expanded, is always the constant. So let's quickly sketch this. Okay, so we have a y-intercept at 2. What else have we got? We got a turning point at 2, -2. And then we have x-intercepts at 2 minus √2. So the square root of 2 is approximately 1.4 from memory. So we're going to be here just below 1. And then 2 plus √2 is going to be about 3.4. So we're going to be just above here. Okay, and I might change the color because it's a bit hard to see. Okay, and then just join your dots. And hopefully it works out symmetrical. If you're drawing it and it doesn't look symmetrical and you think it's not because of your bad drawing, you may have the wrong points. And I did see that once or twice on your last test. Okay, you can't have a parabola that kind of goes like that. Okay, your parabola must be symmetrical. All right, let's do another one. Okie. So this is actually quite difficult. So if you are having trouble with this, don't freak out. Okay, I'm going to do one more example. And then if, hopefully it's one that doesn't have x-intercepts, I can explain that. But if you do have trouble, do ask for help in class. Okay, don't just think you need to rely on watching these videos. All right, I'm going to do question C because I think C will have no x-intercepts. Okay, x squared plus 6x. Take the coefficient of the x, divide it by 2 and square it. Then take it away. And then don't forget your number on the end, which was 9. All right, okay, so y equals x plus 6 divided by 2 is 3. So there's your perfect square. Then we've got minus 9 plus 9. Oh, wow. Okay. So we have x plus 3 squared. Okay, so the minus 9 plus 9 disappears, and I can actually see that, yeah, two numbers when multiplied give you 9. Yeah. So here we have a perfect square. Okay, and you can see that here. So now we actually have a turning point. It's a minimum turning point at -3, 0. I should say minimum. And we have one intercept. And I know there's one intercept because the graph is sitting on your axis because your k is 0. It's neither moved up or down. So when you sketch this, where's -3 over here? Okay, so there's our x-intercept. You can get your y-intercept is your constant, so 9. So just put 9 here. And when you sketch it, I'll do it in red. Just do it symmetrical. So basically, if this is 9, then over here at -6 should also be 9. All right, let's try to choose one that will give you a no x-intercepts. Okay, so we'll do one more. Sorry, let's just see if I can figure one out. I think D will have none. Let's just check. Okay, plus 2x. Good practice to do completing the square though. Plus 2 over 2 squared minus 2 over 2 squared plus 6. So we've got y equals, when we can, sorry, I'll do it all. So now we've got y equals x plus 1 squared minus 1 plus 6 gives you plus 5. Now, I know this doesn't have any x-intercepts because your graph has been shifted up. Okay, when a positive parabola has been shifted up, you have no x-intercepts, so no x-intercepts. Now, your turning point is a minimum. They're all minimums at TP at -1, 5. So when we're sketching it, the only thing we know, -1, 5, well, it's probably not the best place to draw it because we're going to go, but so we've got that point. I've also got 6 as your y-intercept, so it's going like that. So just make sure you draw it symmetrical. So this point here would actually be -2, 6. And you could also just substitute that in if you wanted to draw it perfectly. But you can see there that it's a parabola. I know from what I've written here in turning point form that it doesn't have any x-intercepts. And they're the key features you need to realize about your parabolas, because in turning point form, it's good. You can see what is actually happening with your quadratic or your parabola, but when it's in expanded form or even factorized form, it's a little bit harder. All right, so have a go at the other ones. Make sure you use your calculator to check whether you've done it correctly. I've shown you in previous videos how to do it on your calculator. But again, if you do need help, please make sure you come and see me. Okay, bye-bye.